Hello, welcome to this lesson of our study of integral equations. Okay, so in this lesson we'll go through how to find the eigenvalues and corresponding eigenfunctions of a homogeneous integral equation. Okay, particularly a homogeneous Fredholm's integral equations. Okay, all right, so we have two types or two forms of finding the eigenvalues. We have the one that the kernel is separable, like the first one I have here. Okay, with this one, the kernel here is separable, and this one is degenerate. Okay, so we'll go through them. When it is separable, how do you go about finding the eigenfunctions and eigenvalues? And when it is degenerate, how do you do that? I'll say, okay, so what you will do here is that we'll just pick the first question, okay, that is this one, and go through it. So to find the eigenvalues, what the eigenvalues means is just find the values of lambda when you try solving this equation. Okay, what will be the values of lambda? Okay, so we know that this is an integral equation, yes, but when we try solving this integral equation, what will be the value for the lambda here? Okay, so to solve this, first of all, what you do is just use the method that we know. Okay, the exact method of solving a separable Fredholm's integral equation with separable kernel. Okay, so lambda, then you try to separate your kernel into product of just x and y. Okay, sorry, x and t. So I have e to the x times e to the t, then y of t dt. So since we are integrating with respect to t, all the functions here can remain here, or we can maintain them under the integral sign, and then push the function of x, okay, out. So lambda e to the x, since x is a constant under the integral sign. Okay, so e to the x, integral from 0 to 1, and e to the t y of t, okay, dt. So this is what we have. Then we said that since only this part is functions of t and we are integrating with respect to t, and it's a definite integral, so we'll get a constant. Okay, so this is equal to lambda e to the x times some constant c. Okay, so this is very simple, where our c here is giving us integral from 0 to 1 e to the t y of t dt. Okay, so you could see that if we put the c back, we'll still get back our integral equation, this one. Okay, now let me quote my y of x. We are saying y of x is equal to lambda e to the x, okay, e to the x, then c. And in our last discussion, I said that if you have y of x given as this, when I ask you y of 2, what do? You put in 2 wherever you see x, so you be lambda e to the 2, then c. Okay, so y of 3, or let's say y of 4 or 5, will be equal to lambda e to the 4th power, then times c. So it means y of everything is lambda e to the same thing. Okay, so it means that if I want to find my y of t, so that we can solve our c, because c has everything except the y of t, so we should know our y of t. Okay, then in terms of t, y of t will be equal to lambda e to the t times c. Okay, so this means that my c is simply equal to integral from 0 to 1 e to the t, okay, e to the t, then y of t is what? Lambda e to the tc, then dt. Okay, so my c would then be equal to integral from 0 to 1, okay, then e to the t times e to the t, you get e to the 2t, but we have lambda c here, e to the 2t dt, right? But lambda c, they are both constant in terms of the t. Okay, so what you do is you write c is equal to lambda c out, integral from 0 to 1 e to the 2t the t, right? Then you see c is here, c can divide through both sides of the equation, so c over c here, then the whole of this side over c, and mind you, this can take this out and this can take this, so I have 1 is equal to c divided by c is 1, so I have lambda, then integral from 0 to 1 of e to the 2t, we'll get half e to the 2t again. Okay, integrate e to the something, you just get e to the same thing then over the differential, okay, of that thing. So then from 0 to 1, okay, I hope this is cool. So go ahead and insert our limits. Okay, so I have 1 is equal to lambda into half e to the, when I put 1 is 2t, right? So when I put in 1, I'll get e to the 1. Okay, sorry, e to the t, or e to the 2, sorry, it's e to the 2t. Okay, so it becomes e to the 2, okay, and minus half, then e to the 0. So e to the 0 is just 1, so I have this. Okay, so I have 1 is equal to lambda into the same denominator, okay, half here, so I have e to the 2 minus 1 over 2, right? E to the 2 minus 1 over 2. So if I multiply each side of the equation by 2, okay, I'm really sorry for this. I'm just coming to multiply. I have 2 times 1. Okay, so this 2 can take this out, and I'll have 2 is equal to lambda into e to the 2 minus 1. Okay, so then I can divide through by e to the 2 minus 1. Okay, then this whole thing can take this whole thing out. Okay, I hope you get what I'm trying to say. This whole thing can take the whole of this box out, and I'll get 1. And then here too, if I divide it by that, I'll get this. Okay, so in effect, I have lambda being equal to, okay, so lambda being equal to 2 over e squared, or e to the 2, let me write it well, e squared minus 1. Okay, so this is my lambda, and this lambda is what we call the eigenvalue. Okay, here we are lucky we got only one value for it. If you had gotten 2, 3 values, you are supposed to find them. Okay, so we have just 1. Then we quote our function back. Our answer was y of x is equal to, what did we say we get? We got y of x is equal to, let me see, lambda c, right? So it's lambda c e to the x. Okay, let me put it this way. So therefore, if I put my lambda in here, I have y of x being equal to lambda is what? 2 over e squared minus 1. Okay, then c e to the x. So here c can be varying, so we just leave it like that. So if you write it properly, you get your y of x being equal to 2c over e squared minus 1 all times e to the x. Now this is what students get confused, okay, about it. This is your function, and if you want to find the eigenfunction or the characteristic function corresponding to this eigenvalue, then we take the whole of this constant to be 1. Okay, you take every constant multiplying to a function of s to be 1. So therefore, if you take it to be 1, then you have y of x being equal to e to the x as your eigenfunction. Okay, this is what most books use. Others will tell you that just write the whole of this answer that you've gotten for your y of x to be your eigenfunction. Well, that is also cool, but then mostly this is what you do. You take every constant multiplying to that function of x to be 1, and write that function of x as your characteristic function or your eigenfunction. Okay, I hope this is cool, right? So let's go to the next one, where you have to get 2 values for lambda. Okay, so that one, just pay attention. Okay, so we have y of x being equal to lambda into 0 to, the integral from 0 to 1 of this kernel here multiplying y of t, okay, and then the kernel here is what degenerates, like I said. So finding this, what you do is quickly, like you know how to solve for, that is the exact method of solving integral equation with degenerate kernel. So you multiply your y of t throughout, get 2st y of t minus 4s squared y of t, then all of these dt, right? Then since y of t multiplying everything like that, you can break it, okay, into two different integrals. So I have lambda into integral from 0 to 1 2x t y of t dt minus integral from 0 to 1 4x squared y of t dt, right? And lambda is multiplying everything. So I have y of x being equal to lambda integral from 0 to 1 2xt y of t dt, okay, minus lambda integral from 0 to 1 4s squared y of t dt, right? So I have these. Now with this, how are you going to continue? You just realize that we've gotten separable kernels in each of the integrals, okay? So we have 2x here, I can separate it from t, have 4s squared, I can separate it from y of t, okay? So we just simply go through the other method again, okay? So what you do is you write y of x being equal to, let me quote it back, okay? So I have lambda into integral from 0 to 1, okay, 2xt y of t dt, right? Then minus lambda integral from 0 to 1 4s squared y of t dt, right? So this is what I have. So I can factor 2x out, I can factor 4s squared out. So I have y of x being equal to 2x lambda, okay, or 2 lambda x, let me put it that way. The integral from 0 to 1 t times y of t dt, okay, the minus 4s squared of 4 lambda s squared, okay, lambda is a constant and 4 is also a constant, so I want to write them like this. So 4 lambda s squared integral from 0 to 1 y of t dt, right? So therefore this only integral of a function of t, this only integral of a function of t, and it's a definite integral, so we'll get a constant definitely. So I have 2 lambda x c1 because we have two constants here, then minus 4 lambda s squared c2, or you can call the first constant to be a and the second one to be b. No matter how you call it, it's up to you, okay? Alright, so with this one, what you do is we definitely want to say that our c1 is equal to integral from 0 to 1 then t y of t dt, right? T y of t dt, and our c2 is equal to integral from 0 to 1 y of t dt, right? That is it. Then since we know y of x, we can also find our y of t, okay? So y of x is giving us lambda or 2 lambda x, okay, 2 lambda x c1, right, minus 4 lambda s squared c2. So therefore our y of t will definitely be equal to 2 lambda t c1 minus 4 lambda t squared c2. I hope you understand why I've written this, okay? So therefore our c1, which is equal to integral from 0 to 1, okay, t into y of t is also what? 2 lambda t c1, okay, t c1 minus 4 lambda t squared c2, okay, then dt, right? I hope this is cool. So c1 is then equal to integral from 0 to 1 2 lambda c1, let me put all the constant out, then t squared, right? I hope you get this. Then minus 4 lambda c2 t cubed, okay, or dt, right? So I have this. Then c1, I'm integrating straight. I got c1 equals what do I have here? I have 2 over 3 lambda c1, okay, c1 t cubed, right? I hope you get this. T cubed. I'm integrating straight so you can follow up. Whoa. T cubed, okay, then minus 4 lambda c2 over 4 t to the power 4 c2, then evaluating all of these from 0 to 1. So when I put 1 in, I'll get c1 equals 2 over 3 lambda c1 minus, this will take this out, so I have lambda c2. Right, let me clean this one. This c2 shouldn't be there. I have it already. Okay. Okay, so this is what I have for the first equation, and then if I put this whole thing, or if I take everything from this side of the equation, that is from the right side of the equation to the left side of the equation, I'll have c1, okay, c1 minus 2 over 3 lambda c1 plus lambda c2 is equal to 0, and I have 1 minus 2 over 3 lambda, then c1 plus lambda c2 is equal to 0. That is my first equation, okay, equation 1. Then I go to finding c2. As c2 was given as integral from 0 to 1 y of t dt, okay. So you just quote your y of t in. Y of t, we said, is equal to what? Y of t is equal to, let me see, 2t lambda, or 2 lambda c1. Okay, so 2 lambda c1 t. This is what we had, right? Then minus 4 lambda t squared, or 4 lambda c2. C2 is here. C2 c squared. T squared or something like that. Okay, so I have this dt. So if I integrate this one straight away, integrate and you get 2 lambda c1 t squared all over 2 minus 4 lambda c2 t cubed all over 3, right? Then evaluate everything from 0 to 1. So I have c2 being equal to, this will take this out, so if I put 1 in, I'll have lambda c1 minus 4 over 3 lambda c2. Now the reason why I don't put the 0 in is that when you put 0 in, everything will be 0, so you just evaluate it at 1 and that is all. Okay, so if I try to simplify this, I'm taking this c2 to this side of the equation, okay, so it becomes minus. I hope you get what I'm trying to do here. So that I want to make sure that the c1s are standing alone, okay. So what will happen is that, or the c1s are positive, so I'll have lambda c1 minus 4 over 3 c2, okay, c2 minus c2 is equal to 0, okay, and I'll have something like lambda c1 minus, into bracket, 4 over 3, this is lambda, there's a lambda here, right? It's 4 over 3 lambda. Okay, yes, there's a lambda there. So I have 4 over 3. Let me write it well. 4 over 3 lambda minus 1, or sorry, plus 1. Since I've factored the negative 1 out, c2 equals 0. Okay, so this is equation 2. I have the first equation to be the first equation is what? I have 1 minus lambda, right? So the first equation is this one. I have 1 over this one. Okay, that's this first equation. 1 minus 2 over 3. So 1 minus 2 over 3 lambda c1. Okay, c1. Then minus, is it minus? What is the first one? The first equation is this. Okay, my plus is plus, rather. Lambda c2 is also equal to 0. This is first equation that we had. Okay, so we can actually put this in a matrix form. Okay, you should put this, or you can make one of the C is the subject in one of the equations, then you make substitution. Okay, you can make C2 the subject in this equation, then you substitute it back in this. That is, you tell your lecturer or your teacher that solving it by a substitution rule or using the method of substitution, C2 from equation 1 equals this, and then you come and substitute it here. Or you can also make C1 here the subject in the first equation, come and put it here, and then your equation will turn into only one variable. Okay, and you solve it. But personally, this is what I would do. I would put this whole thing in a matrix form and say that I have the first equation, I have 1 minus 2 over 3 lambda, okay, then lambda for C2. Then with the second equation, I have lambda, then negative into 4 over 3 lambda plus 1, then C1, C2. All of these equals 0, like that. That is a 0 vector. So in effect, this is what we have. We have an equation of this form, that is a matrix 1 minus 2 over 3 lambda, then lambda again. Okay, I have lambda here again, then minus into 4 over 3 lambda, then plus 1 from C1 and C2. This is equal to 0. Now I realize that using Kramer's rule may not work here, because we have to put the 0 vector in place of the first column to find our C1, and then you realize that the determinant will be 0 over something. Okay, and you may be thinking that the answer is C1 and C2 are both zeros. No, please. So what you have to do is use your idea in the characteristic polynomial and matrices. Okay, that define the eigenvalues and eigenfunctions. Okay, so we know that both C1 and C2, this vector is not equal to 0. Okay, then it means that the determinant of 1 minus 2 over 3 lambda, then lambda again, minus 4 over 3 lambda plus 1, the determinant of this should be equal to 0. Okay, this is what you do. Like I said, you could use the method of substitution, but then for that one, when you have a 3 unknown, that is C1, C2, C3, you may be finding it difficult. So I hope you stick to this and tell your lecturer that using this method, okay, using the characteristic polynomial method, the determinant of this should be equal to 0, and this shouldn't be equal to, that is, the C1, C2 shouldn't be equal to 0. With that, find the determinant is just multiplying these. Okay, then you subtract the product of this and this from it. So this times, let me do it this way. Let me use the red one. So the product of the red arrows, okay, so this one minus the product of the green arrow. Okay, so it's this time that, and you subtract them. Okay, so when you do that, this is what you will get. Let me write it on a different page. And you do that, you have negative of 1 minus 2 over 3 lambda. Is just a positive of that, but then when there is a negative in front of the 4 over 3 lambda plus 1, that is why I have negative of that, minus the product of lambda and lambda again, okay, should be equal to 0. That is the determinant. And so if I divide through by negative, I'll have 1 minus 2 over 3. Let me write it well. 1 minus 2 over 3 lambda, okay, then times 4 over 3 lambda plus 1 plus lambda squared should be equal to 0. I just divided through by negative 1. Okay, so when you expand this one, you get something like 1 plus 4 over 3 lambda, okay, then minus 2 over 3 lambda. Okay, I'm doing my multiplication, so you can go through it. H over 9 lambda squared plus lambda squared should be equal to 0. So I simplify this by multiplying through by 9, and I'll have 9 plus 12 lambda minus 6 lambda minus 8 lambda squared plus 9 lambda squared should be equal to 0. Okay, then I'll continue by simplifying. I'll have lambda squared, okay, lambda squared, let me do it this way. Lambda squared plus 3 lambda, okay, plus another 3. Is there any 3 lambda here? Sorry, plus 6 lambda, okay, plus 6 lambda, 6 lambda, where is my 6 lambda, okay, plus 9 is equal to 0. So here you are solving for lambda. So what you can say is that using the method of factorization of quadratic equation, or you can say that using the quadratic formula, then you state it straight away and then you find your answers. Okay, I hope you get my point. So all I need to do is just state what we want to use. We want to use the factorization method. So lambda squared, is it plus, okay, so we have plus 3 lambda plus another 3 lambda, because when you add it you get 6, but when you multiply you get 9. So that is what you want to do. And plus 9 equals 0. Actually what you do is find the coefficient of lambda squared, that is 1. You multiply it to the c, which is the 9, and you get 9. So the product of, or the factors of 9, that when you multiply you get 9, but when you add you get 6, is 3 and 3. Okay, I hope you get the point. So I'm using that old formula that you know. Okay, so you factor these ones, okay, and factor lambda out from the first bracket. I have lambda squared plus 3. And I factor 3 out from this one. I have lambda plus, sorry, the first one you factor lambda out, you get just lambda, okay, plus 3 equals 0. So I have lambda plus 3 is equal to 0. Okay, so I have lambda equals -3 or lambda equals -3. So I have repeated root here. So lambda 1, lambda 2, they are both the same. Okay, so lambda 1 equals lambda 2, and it's equal to what's -3. Okay, so you can go ahead and put lambda 1 and lambda 2 in both equations 1 and 2. Okay, so you have equation 1 to be this one. I have c1 into 1 minus 2 over 3 lambda, okay, plus lambda c2 to be equation 1 equals 0, sorry. And I have the second equation to be lambda c1 minus, is it minus? Yes, minus, or let me go and check, 4 over 3 lambda plus 1 or something like that. This is what I have. C2 is equal to 0. So you can go ahead and check it. Okay, where is our C1 C2? The first equation is 1 over 1 minus 2 over 3 lambda, like that. Okay, everything is cool, I think so. So this is what we have for, so lambda is equal to, we have repeated roots, -3, right? So you come and put -3 here, and when you put in the first equation in place of this lambda, okay, we'll get c1 into 1 minus 2 over 3 into -3, right, plus -3 times c2 is equal to 0, and this will take this and you have -1 like that. So I have c1, okay, then here will be 1 minus 2 times -1, here will be -1, so I have plus, so it become 1 plus 2 like that. Okay, so I have 3c1 minus 3c2 equals 0, and this implies that we have c1 minus c2 equals 0. So then c1 is equal to c2. This is what we have. Okay, c1 is the same as c2. So you go ahead and do same for the second equation and see if you can get this is the second equation. Okay, so if you put it there like that, and you put it in the second equation at the same time, you get minus c1. Let me see, when you put it in the second equation, let me put it there and write the outcome there. Okay, so I'll have minus 3c1 when I put it there, plus 3c2. This is what you get. So just go through it and see if you get the same thing, equals 0. So it means when I divide through by -3 or 3, I have -c1 equals -c2. Okay, and in the end c1 is equal to c2. So both equation is giving us the same thing. What you do is just go ahead and write your y of x, which is equal to negative, what was y of x was let me go ahead and write it back. my y of x was giving us 2x, okay, lambda c1 minus 4s squared lambda c2. So we know our lambda, so y of x is equal to 2x, lambda is -3, c1 is c1, minus 4s squared, lambda is -3, c2 is equal to c1, so we just put c1 again here. And this means that y of x is equal to minus 6x c1 plus 4, is it 12 or 4? 12 s squared c1. Okay, I hope you get what I'm trying to get here. So you have c1 in both sides, and 6 can goes into this, or the two of them. So we have y of x being equal to minus 6 c1. Let me come back and check. So I have plus 12 here. Okay, so if I factor -6, I'll have to get a negative something inside the plus. Okay, so I have x plus 2s squared, or it should be minus, right? X minus 2s squared rather. Okay, so x minus 2s squared, and this will be our solution to the question. Now we know our eigenvalue to be -3, that lambda 1 lambda 2 equals -3, and then the eigenfunction here is, you can say that you take the whole of -c1 -6 c1 to be 1. This is a whole constant. Okay, so you take it to be 1, and you have your eigenfunction y of x to be equal to x minus 2s squared. Or you can also as well go ahead and say that, oh, y of x is equal to, now factoring 6 c1 out, then you have minus x plus 2s squared. Okay, I hope you get this. So if you factor only 6 c1, then that one, so you can contain this or take this c1 as your constant, and you get another eigenfunctions be given as -x plus 2s squared. You see that since we have repeated, we are getting 2 eigenfunctions. Okay, so thank you, and don't forget to subscribe to my channel. Any question that you don't understand, particularly on this video, just comment in the comment section below, and then like my video, share it, and like I said, comment as well. Okay, thank you, and see you next time.